Hello explorers and welcome to another video. Today we are going to talk about MySQL and having it replicate correctly. In this case we are talking about a way of having redundancy for your database. We've already looked at how to do it with Postgres and Percona and so on, and now Patroni, and now we're going to look at how to do it with MySQL. And at work we are running a lot of MySQL instances and we are using this asynchronous replication where a server could replicate another server and that server in turn could replicate the first server, and you could have a lot of different read-only databases and so on that you are replicating to. But what you really want is to have a network of a bunch of different MySQL servers, and if a couple of them disappears from the network, you should still be up and running. And that's where group replication comes in, or InnoDB clustering. So this kind of group replication is a way of setting up a system where you have a stable system where you can lose a bunch of MySQL instances without having any loss of data. And it works with a formula with n times 2 plus 1. So for instance, if I want one of my servers to be able to go down for maintenance or for other, I would just take that times 2. So we have 2 plus 1. So we need 3 MySQL servers in order to take down 1. If we want to take down 2, we do the same calculation and need 5 servers, and so on and so on. So and you could have 6 servers, but you don't get any extras. So if you have 6 servers, you still can take down 2, not more than that. So this is what we're going to set up today, and let's switch over to my screen here. I'm going to set up a 3 cluster environment. And the first thing we always do in this is say that this is a Debian system, no extra packages, it's just a totally clean install. I even have a video on the subject where I talk about how to do a clean install of Debian and do that automatically. So I've run that through. So we don't have any extra packages here. So I first do a sudo update. So we update so we get the latest packages in the repository, and if I can type QWERTY correctly we can get started here. Next up we're gonna install a couple of packages here, vget to get packages for MySQL. So we're gonna use the normal MySQL repository for community, and we need lbs release because that is used by the installer, and also GNU PNG to encrypt the keys and so on and handle those. So we need those packages there. Next up we're gonna add a key to the repository, and we're gonna use one of the key servers to add that key. So it's apt add and then receive a key from the key server, and then a particular hash for that key. And this is deprecated, but we still will get that down, or perhaps it's just missing that key, but I think it should be fine anyway. Then next up we are running the vget to download this Debian package to configure our Debian environment, and then we're gonna run that deb package. So all of these are things that are documented on their sites. I'm just following their guidelines here. So, and here I'm saying, okay, I want the LTS supported version, I want the connectors, and just okay. So now I have that package installed, and we need to run this on all our servers, and I have 5 of them, so 3 MySQL servers, and I also have 2 routers that we're going to use later on. So let's get this process started here on all the servers, and there we go. And the last one. And let's get back to the first one. And now we're going to do an update again. And the reason we do that is because now we have added an extra repository here. We have added a bookworm repository for MySQL. I've tried this with Trixie, but currently I'm running a setup that is more akin to what we are running in production at the moment. We haven't upgraded to Trixie yet, so that's why I'm doing it on Bookworm. It works just as fine on Trixie, so if you want to do that instead, that's just fine. I have tried both. And what we need to install on the MySQL servers is MySQL server, of course, and something called MySQL shell. And we're going to get back to that feature later on, but we're going to install that. So let's do that on all three of the MySQL servers. Let's see here. Let's do OK on those. And let's see. Did I copy the wrong thing here? There we go. And the same goes for this one. Let's not copy the bash part. There we go. And on the routers, we're going to do a little bit differently, because here we're going to update and we're going to install MySQL router community, the client and the shell. So a couple of same packages, but not all of them. So let's go. So now that we have done that, we will get back to the first server here, the MySQL server, and it asks for a root password. And I'm going to just use QWERTY. Of course, you're going to need a really good root password for all your servers. I'm going to use the same password for all of them, because for this proof of concept, security is not the most important part. So this will install a bunch of packages, and that will take a little while. So I will get back to you when that's done. And we're back. And now we have installed all those packages on all 5 servers. And these are virtual servers on my machines. That's why it takes a little while to get it up and running. But next up, I'm gonna run a script called MySQL shell. So mysql.sh. And when we run that, we will get into a system where we can talk to MySQL instances using different languages. And it supports SQL, which is the normal SQL language, but you also can use JavaScript or Python. And we're going to switch over to JavaScript here, so \JS, switching to JavaScript mode. And in this, we can connect to the server using one of the different methods here. So for instance, there is something called a DBA, and that has a couple of different settings on it. So we could configure instances, we could check that the configuration of our instances lends as well to creating a cluster. We can create a cluster and so on. So here we can check first the configuration of our instance, and we need an open connection for that. I'm wondering if we just can do root at localhost 336 like that, provide the password, and let's store that password. New connections with proper source addresses specification to allow remote connections. Okay, so new account. We need to create an account, but I think the configure instance can fix that for us. So let's see. DBA configure instance root localhost. So was that allowed? Yes. So let's see here. Remotely use create a new account for our InnoDB cluster, and then call that cluster admin and give it a password. We do the same QWERTY password. And now we can see that we have a couple of things that are incorrect here. First off, the server ID needs to be different on each server. And we also need to turn the consistency on. So do you want to change these configurations? Yes. And we'll restart it. Yes. So now we should have a unique server ID, and we also should have the GTID, which is an global identifier for each row in the database. So when you do changes, it will give this global identifier to all the different MySQL questions, and that is the way it can sync it through the other systems. And it also gives them an order. So if you have multiple systems and they are sending traffic to each other, and very much similar to TCP, where the packages can arrive in different order, it will still figure out, have I got all the packages? And then when it has gotten all the packages in the right order, it then applies them. So that's the thing that this is using, this GTID, and it's very important to have that in order to get up and running. So I wonder if we just can run MySQL shell on the other systems and just configure them. So DBA configure instance, and just run root localhost 336, and we provide the password, and remember the password. We want a new account, cluster admin, and we give it a password. And it asks the same questions here. So it seems like even though it was gave us a little bit of an error before, it was just fine to configure it, because the error was pretty much you're not configured yet. So then just do that. DBA configure instance, and we do root localhost 336, and let's do password. Do the right password. Remember that. New admin, cluster admin. So it was a while since I wrote this script, because I was looking into how you could migrate from an existing cluster into this cluster. And the way you're doing that is pretty much checking that you have all the prerequisites that we have here, see that you have turned on this GTID, and then migrate that over. And you can switch it over in a way that you're turning on this GTID mode from off to on, but you're doing it in a permissive way. So first you have off permissive, which is you allow this to be a thing that you send around, but you're not applying it. And then after that you go to on permissive, which means that you are sending the value, but you are allowed not to use it. And then to go to on all servers, which means that it's required and it's sent all over the place. So you can gradually go over to a system that actually works with this. And the same way goes for making a cluster, where you can have this asynchronous mode to send data over to another system. And then you say that one of the replicas should be your cluster primary. So you create a cluster on that one, and it still will give you an error and say that you can't do that on an asynchronous system, and you allow for that error because you know that you're just migrating over and you're going to do it really carefully. And you turn it on there, and then you add more nodes, more members to this cluster, and then you switch over the original one over to this system. So there is a way to do this online. It is a little bit more complicated, and the recommended way to do it, if you can, is to take everything down, stop the traffic to your servers, set up the cluster environment, so take away the asynchronous replication and turn on this clustering instead, and then turn on the traffic again. That is the safest way of doing it, but you can do it online. It's a little bit more complicated. So now that we have set up all these 3 servers so they can be clustered, we will enter the first one again. And here we will connect to the first server using our cluster admin account and our password again. And remember that password. On this first server, we want to create a cluster. So let's just call it My InnoDB Cluster and then create it. The name can be pretty much anything, but you need the name in order to find it again. So you can say DBA get cluster and then the name, and you will get this cluster back. But now that we have created this cluster, we can add instances. So we do that with just add instance and the cluster admin and the other server. So my2, for instance. And here we get a choice if we either want to clone the instance, so you take and send over a full copy of the first server and then start the replication from there, or if you want to incrementally switch it over. So let's try cloning first. So here it will check and then copy the database over and start. So you see file copy, page copy, redo copy, and then shutting down the server and then restarting it again in order to get it into the system. And we haven't really added any data to this database, so it's pretty quick. But if you have larger data sources, so you have a really large database, then I would suggest to do an incremental instead. So let's check cluster status. Now we see that we have 1 primary and 1 secondary. And the primary is read-write and the secondary is read-only. So let's add the third cluster member here. And it's pretty much the same, but we do an incremental instead because they are very similar. So it should catch up very much faster if we do incremental. So it's just switching over, waiting for the distributed recovery to finish, and it finished, and now it's over. So if the databases are in the same state, so you have already a copy on the other one, and the database is still getting reads or writes, this is the way to go because it's faster. The cloning way is replacing everything and then catching up in this way, and that is if you have an empty database, that is much faster. And this incremental is if you have databases that are very similar and you just want it to catch up, then that is faster. So now we have 3 members. You can check the cluster status. So now we have 2 secondaries and 1 primary. And next up, we will set up the router. So let's go over to one of the router machines here. And first off, I want to create a user. So we're going to create a MySQL router user. User add, shell, bin bash, system, the home directory, var share MySQL router. And this is the MySQL router and the username MySQL router. So now we're going to create that home directory. So we just do make dir of var share MySQL router, like that. And then we're going to give the right permissions to that. So the group and the user MySQL router will be the owner of that directory. And now we need to bootstrap our router. And we do that with the primary of our cluster. So we say MySQL bootstrap with cluster admin, my1ea.org 336. So that's my first instance in the directory of var share MySQL router, the user MySQL router. And it will ask for the cluster admin password. And now it's going to create a cluster instance or a router instance that we can later start with this command up here. And when it's done that, it can either use the classical MySQL protocol, which you probably will use, or the MySQL X protocol. And the interesting thing here is that you get 3 different ports. So if you have a system where you already in your applications can figure out that this is a read-write operation or this is a read-only operation. You can separate these and send them to different ports on your router in order to ensure that the read-only requests are separated and sent to a bunch of different read-only servers, and the read-write requests are separated and sent to a bunch of different read-write servers. And what did I say there? Read-write servers. Because you can set up this way of global replication or this group replication and have a multiple write if you have that requirement. Usually when it comes to databases, you have a lot more reads than writes, but nothing says that you need to have it that way. In some cases, you use a lot more writing than reading, then you will set this up a little bit differently. And last, you have this split connection. And I have tested this, and you can get it to send all the read requests to read servers and distribute them over those, even on this port. The only thing you need to do is set the whole transaction on that connection. So when you're connecting to the database, you do one command and say this particular request is read only. So I'm not sure if I have an example of it here. No, but you can set that the full transaction or the full connection is read only. And when you do that, the rest that you send to this connection will be read only and split over, and you don't need to do different ports, but you still need to do an extra step for every read only. And the reason is that it's really hard to figure out if this connection will do a read and then a bunch of writes and then a read or so on. So it's a little bit of a dumb router, but having that capacity to figure out that this is safe to do a read only and this is safe to do a write, it's complicated. So they didn't want to go into that here. Next up, we're gonna get this router set up so it actually will be running the correct way. So first off, we're gonna remove an initd script that is installed by default. So we're gonna replace this with a systemd service instead. So let's go in here and create a systemd service. And here I'm gonna copy paste some data into that. So my SQL router service, it needs network to be online, multi-user, and then you just have a runtime directory. It's a simple MySQL router is the user, and then we have a PID file, and then the particular start script that we have down here. So nothing that revolutionary, very simple. And then we're gonna reload our daemons, so we have the latest, and we're gonna restart our MySQL router, so it will use the new configuration. And then we can enable and also check the status, and we see that it's up and running. Yeah, so now let's go back to my first server here, the MySQL server. And I'm gonna connect to the first one again, which we are already on. I'm gonna switch over to SQL mode. So now we can see that we have that turn on, show databases. So we have a couple of databases here. We see now that we have an MySQL InnoDB Cluster metadata here as well. And I'm going to create a test database. So let's create a database, sbtest. sbtest identified by password, super secure, and then give all privileges to that test. Our cluster admin is not allowed to do that. So let's try to reconnect to localhost again using root. So we have more access, and then switch over to SQL. So it's kind of fun that we can do just move over like this. So now we have created that user, and we have given it privileges and created the database. So if we look at the databases, we have an sbtest. And now I can do a command called top h with the PID of MySQLD. So now we can see how much MySQLD is working here. And I'm gonna do that on all my servers. So we can have a little bit of a check that we get a distributed load. So first off, we can see that we are running on 3% of CPU on the different. So it's doing things, but not that much. So now the first thing I'm gonna run is I'm gonna install the Sysbench on this router. And Sysbench is a script that can do testing of different services. And if we're gonna do that with MySQL, there is a command to prepare a database with a bunch of data. So here we have Sysbench, and we give it a Lua script with a bunch of data in there. We say that we want to use the MySQL driver, the MySQL user of SPTest, MySQL DB of SPTest, but password is password. I'm going to use this port where you can have both read and write requests. And we know that that will mostly hit our write server because we haven't said that this could be read request. We want 20 tables, and the table size should be 100,000 rows. And if we prepare that, we see that it starts to create a table here of SPTest1 with an inserting 100,000 records. And now it's going to try to create the second one. And if we look here, we have 21% of utilization, 40% utilization on the first one here. And we see that we have 26 on the second, so it's replicating things over. And we have 90% on the third one. But we see that there is traffic going to all the servers, moving data over and preparing all of this so we can have a bunch of data on all of them. So I'm going to wait for this to complete, and then I will get back to you. So now we have prepared a bunch of database tables, and we now want to do some write operations to run a test here. So I'm going to run a test against this R1 server. So the host R1, 20 tables, table size of 1,000, 100,000. And we're going to use this port for read-write operations. And we're going to use a read-write Lua script. And it's going to report every 2 seconds or so. So now it's doing a read-write operation. And we haven't separated much. And we also can see the number of errors per second out here. So no errors at the moment. And if we look at the load here, we can see that we have a little bit of load on the system, but not as much as we had before. What I want to do now is to check our status of MySQLD. And we have it there. Let's do a stop on that and see what happens. Haven't tried it yet. It's going to be interesting. See if we get any errors. Yep, we got an error, lost connection. Let's start it again and see. Now, so we got one lost connection, of course, statement. I think if we had multiple connections coming through, it would still continue working, even though we had lost connections, because it will switch over to another server. So let's see. Takes a while for MySQL servers to stop fully, but we see that we still have load on the other servers here. Was a little bit sad that the Sysbench stopped on error, on connection errors. I would like if it just had continued and just presented me with one error. But that was not the case. So now if we check the status, we can see that this is stopped. If we go into MySQL shell and then connect to one of the servers here, let's see, We can connect to the second server, for instance, and give a password here. And remember that password. And we will get our cluster and check the status here. What does it tell us? Now it tells us that number 2 is primary, number 1 is secondary, but it couldn't open the connection to that one, so it's missing. And then we have number 3 is a secondary as well. So let's start our server again. And hopefully that will not disrupt anything. It will just continue here. So now it's started. And if we go back here, connect again to our cluster, get the cluster, and then check status, we should have this recovering up here. Distributed recovery process. And here we see that you have a replication drag. One of the servers. Let's stop this one, just so they will catch up. Because the load on the server is probably not that heavy in most systems, so it should be able to be recovering. I will get back to you when it has recovered. And directly when I stop the recording, it's recovered. So it took a little while, but it has now recovered. So all of them is up and running. My one is secondary. The next test I want to run is a read test, because I wanted to separate the reads over the first instance and the third instance, and nothing on the second instance, because that's a write server. So if we are running a load on Sysbench where we are only doing read-only requests, and we are using 6447, which is the read port, it should load balance this over the 2 servers that we have. So if we check 1 here, we see that, or 2, we see that it doesn't have any traffic at all. CPU 6%, so that's what we saw earlier. If we go back to instance number 1 and check here, we have 25% of the CPU is used for this. And if we look at 3, it's using 3%. So it didn't load balance that much. We still have most of it on the first one. Would like to see a better load. So let's see if it has to do with the connection. So let's go to the second server and do a similar run. But yeah, and we need to install Sysbench on this server, of course. So we will simulate a load of multiple users. Could have more threads, for instance, on Sysbench, but these servers are pretty limited. So now I'm using 1 thread on each. So now we should see a load here as well. Yeah, 22% on this server and 27% on this server. And we still don't have any load on the right server. So this means that the connections that comes in will be distributed in a manner between the different servers, depending on if you have multiple read or multiple writes. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you have any questions or suggestions, leave those in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.